The year 1942 became a turning point, not only for the entire Second World War, but also for the development of armoured vehicles on a global scale. After the catastrophic defeat at Stalingrad and the crushing failure of Operation Citadel at the Kursk Bulge, the German military command found itself in a state of deep, systemic crisis. Soviet T-34 and KV-1 tanks demonstrated undeniable superiority over the best German vehicles, while Allied industry increased production at an alarming rate, exceeding German indicators fivefold. It was at this critical moment that the concept of Wunderwaffe was born in Hitler's headquarters, a miracle weapon capable of turning the tide of war with a single stroke and returning the strategic initiative. Adolf Hitler, who always had a weakness for gigantomania and technical miracles, personally formulated the requirements for the new weapon at a secret meeting in the Wolf's Lair. We need a tank that will be absolutely invulnerable to any enemy artillery, capable of destroying any fortifications with a single shot, and whose appearance will sow panic in the enemy ranks. This must be a steel colossus, without equal on the battlefield, a symbol of the power of German weapons. His words met with approval, although many experienced generals remained skeptical. Thus began the history of the most ambitious, mysterious, and controversial tank project in human history, Pz.Kpfw, VIII Maus. The ironic name Maus was chosen as a mockery of Allied intelligence, who would look for a mouse weighing almost 200 tons. But behind this humorous name was hidden one of the most resource-intensive and insane projects of the Third Reich, which consumed colossal funds and the efforts of Germany's best engineers at a time when the country desperately needed simple and reliable tanks. The development of the super-heavy tank was entrusted to Ferdinand Porsche, a brilliant engineer, creator of the people's car Volkswagen, and one of Hitler's most trusted technical advisors. Porsche received unprecedented powers and access to resources, despite open skepticism from many high-ranking military officials, including Guderian himself. A real departmental war for influence and resources unfolded between Porsche and traditional tank builders from Warproof 6. The project received the highest level of secrecy, codename Object 205. All work was carried out under conditions of strict confidentiality. The workshops of the Alket plant in Berlin were surrounded by a double ring of SS guards. Every employee underwent a multi-level Gestapo check with biography study up to the third generation. Interestingly, most engineers and workers did not know until the very end what project they were working on. Such a system was supposed to prevent information leaks. Even the drawings were divided into parts, and only a few people had an idea of the full picture. Porsche proposed a revolutionary concept for that time. Instead of a traditional mechanical transmission, use an electromechanical system. The essence of the solution was that the internal combustion engine drives a generator that produces electricity for motors installed directly in the driving wheels. Such a system provided unprecedented smoothness and ease of control, but significantly increased weight and complexity of the design. Many specialists openly called this idea insane for frontline conditions. The technical specifications amazed with their requirements. Frontal armor thickness, at least 200 mm side, 150 mm rear, 150 mm bottom, 100 mm. Main armament, 128 mm gun, with ammunition of at least 40 full-charge rounds. As additional weapons, 75 mm gun with 200 rounds, an MG-42 anti-aircraft machine gun with 1,000 rounds. The preliminary weight of the structure was estimated at 150 to 170 tons, which already then caused open skepticism among experienced tank builders familiar with the realities of operating heavy equipment. Hitler, having familiarized himself with the initial sketches, was absolutely delighted. This is what I dreamed of. This will be the very fist that will crush any enemy defense. I want to see this tank in metal as soon as possible. He personally approved the project and ordered the allocation of all necessary resources, despite objections from some sensible generals who pointed out the absurdity of the project in conditions of total war. The development of Maus became a real challenge for the entire German industry. Each tank unit broke records in size and mass. The turret, weighing 50 tons, became the heaviest in the history of tank building. For its production, it was necessary to modernize the workshops of the Krupp plant and install new overhead cranes with a lifting capacity of 60 tons. The 128 mm Kpfw L55 gun could penetrate 200 mm armor from a distance of 2,000 meters. No Allied tank had such protection at that time. The armor-piercing projectile weighing 28 kg left the barrel at a speed of 920 km/h, which provided colossal penetrating power. The chassis included 24 road wheels per side, assembled into 12 bogies with individual torsion bar suspension of special design. Each torsion bar had a length of 2.8 meters and a diameter of 70 mm. The tracks with a width of 1100 mm were made of special vanadium alloy steel. Each link weighed 45 kilos and had a complex geometry to improve grip on the ground. For comparison, the track of the Soviet T-34 tank weighed about 15 kg per link, and the German Panther 25 kilos. The total weight of only the Maus tracks was more than 8 tons. The power plant became a headache for engineers. Initially, a Daimler-Benz MB-517 diesel engine with 1200 HP was planned, but its development was constantly delayed due to problems with the injection and cooling systems. As a temporary solution, they chose the Daimler-Benz MB-509 aircraft engine, a V-shaped 12-cylinder unit with 1080 HP running on gasoline. This decision caused criticism. The gasoline engine was more fire hazardous and had a high specific fuel consumption, 320 HP per hour. The cooling system included 2 radiators with a total area of 18 mb and 4 fans with a diameter of 600 ml each. The most innovative solution was the system for overcoming water obstacles. The Maus was too heavy for most European bridges, maximum load usually 40 to 60 tons, so the engineers developed an underwater driving system. The tank could cross rivers up to 8 meters deep along the bottom. For this purpose, the hull was sealed with special rubber gaskets 30 mm thick, and an 8-meter snorkel of complex design with ball joints was used to power the engine. The crew of 6 people was in a sealed compartment, using individual breathing apparatus in case of depressurization. The system was tested in a special pool and showed the ability to operate for 45 minutes underwater. The fire control system included a Zeiss stereoscopic rangefinder with a 1.2-meter base, Sperber infrared night vision devices with a range of 400 meters, and an electromechanical correction calculator for wind, air temperature, barrel wear, and target movement. Incredibly complex and advanced equipment for the mid-1940s. The cost of optical equipment alone exceeded the cost of an entire Pz.Kpfw tank. The first Maus V1 prototype without a turret was ready for testing in December 1943. The test site in Kummersdorf had to be significantly strengthened. Ordinary concrete roads could not withstand the weight of the giant. For testing, special reinforced tracks with different types of surfaces were built. 25 cm thick asphalt, 40 cm thick concrete slabs, and soil sections with different load-bearing capacities. A special test bench was also built to test cross-country ability, with climb angles of up to 25 degrees. The very first tests revealed catastrophic problems. The maximum speed on the highway was only 22 km/h, and on rough terrain, no more than 13 km/h. The specific power, 5.7 HP per ton, was half the minimum required for a tank of this class. For comparison, the Soviet IS-2 had a specific power of 11.3 HPT, and the German Panther 15.6 HPT. Acceleration from standstill to 20 km/h took 35 seconds, an eternity in combat conditions. But the main problem was cross-country ability. Despite the wide tracks, the specific ground pressure was 1.4 kg, sim.2. The tank sank into soft ground to a depth of 0.8 meters and turned asphalt roads into piles of rubble after several passes. The test report by Captain Müller stated, "The Maus cannot move on most German roads without their preliminary reinforcement. In autumn, muddy conditions, it becomes completely helpless. Country roads are generally excluded from possible routes. Even driving across a field after rain is impossible. The tank immediately gets stuck." Fuel consumption reached 450 litres per 100 kilometres on the highway and 700 litres per 100 kilometres on rough terrain. With a fuel tank capacity of 2,650 litres, the range did not exceed 160 kilometres on the highway, ridiculously small for a breakthrough tank. For comparison, the Soviet T-34 had a range of 400 kilometres and the German Panther 250 kilometres. Just to move the Maus 100 kilometres required 4.5 tons of gasoline, the same amount consumed by a company of 12 Panthers over the same distance. The second V2 prototype with a turret was ready in June 1944. Weapons tests showed excellent results. The 128mm gun hit targets at a distance of 3,500 meters with high accuracy, circular probable deviation 0.3 mm at 1,000 meter. But the recoil when firing was so powerful that the entire tank shook, and the turret rotation mechanisms experienced extreme loads. After a series of 10 shots, inspection and adjustment of all turret components was required. The loading system allowed no more than 3 shots per minute, a very low rate for a breakthrough tank. Albert Speer, Minister of Armaments, wrote in his diary, "The Maus is a monster that devours resources that would be enough for 20 Panthers. Each of its shots costs as much as a fighter flight. Hitler does not want to see the obvious. This machine is useless in real war. This is an expensive and helpless giant that will never see the battlefield." Nevertheless, work continued on the direct orders of the Führer. Transporting the Maus to the front line became a separate, unsolvable task. Conventional railway platforms had a carrying capacity of 60 to 80 tons. To transport the Maus, it was necessary to develop special 16-axle transporters 30 meters long and with a carrying capacity of 200 tons. Each such transporter consisted of 2 sections connected by special hinges and had its own braking system with pneumatic drive. Each transfer of one tank required preliminary strengthening of the railway track along the entire route, laying additional sleepers, strengthening the ballast layer, dismantling all obstacles, platforms, canopies, signalling devices, contact network, in areas with small dimensions, ensuring a special traffic schedule with a minimum speed of 25 km/h, involving 2 powerful Series 52 steam locomotives for traction on the plain, and 3 in mountainous areas. Escort by armed guard consisting of a platoon with anti-aircraft installations. Transporting one Maus required resources sufficient to transfer an entire tank battalion, about 50 vehicles. In field conditions, to service one tank, it was necessary to create a special repair company consisting of 2 repair vehicles on Panther chassis with crane equipment, 4 heavy FAMO tractors for evacuation, 8 Opel Blitz trucks with spare parts, 2 fuel tankers with a capacity of 5,000 litres, special crane with a lifting capacity of 200 tons on a tracked chassis, 2 engineering vehicles for route preparation, a platoon of sappers to strengthen bridges and roads. Colonel General Heinz Guderian, Inspector of Armoured Forces, wrote in a report, "The Maus is the worst thing that could happen to our tank forces. Instead of concentrating resources on the production of proven Panthers and Tigers, we are wasting energy on technical fantasies that will never bring practical benefit. This tank cannot even get to the battlefield on its own. Every kilometre of its path requires engineering preparation, and its maintenance distracts entire units." Nevertheless, Hitler continued to insist on continuing work. He believed that the appearance at the front of even several such monsters would demoralize the enemy and change the psychological situation at the front. In his view, the Maus was not just a tank, but a symbol of German technical power that was supposed to show the superiority of German engineering. There is numerous evidence that the Maus was planned to be used as a platform for testing new types of weapons. The archives contain drawings of a variant with a flamethrower, with a range of 100 meters and a consumption of 5 liters of fire mixture per second, as well as an installation for spraying toxic substances with a 500-liter tank. A variant with rocket weapons was also considered. Unguided 200-Meter rockets with a launcher for 6 missiles. The most intriguing is the version about the project's connection with the Nazis' nuclear program. After the war, mentions of a mobile platform for special physical devices were found in the documents of physicist Werner Heisenberg. The Maus, with its powerful armor and huge internal volume, was ideal for transporting a compact nuclear reactor or tactical nuclear charge. It is known that in 1944 experiments were conducted on shielding electronic equipment from electromagnetic pulses, an undoubted sign of work in the field of nuclear physics. In 1944, secret experiments with active protection systems were carried out at the Kummersdorf test site. The Maus was equipped with 2 kDa infrared spotlights and third-generation Sperber night vision devices, technologies that would appear on production tanks only 20 years later. A system of an optical rangefinder with a laser target designator, a prototype based on a ruby laser, was also tested. The accuracy of distance determination was +3 meters at a distance of 1,000 meters. There is a theory that the electromechanical transmission was developed not only to improve driving performance, but also as a source of energy for future energy weapons. Sketches of a variant with an additional 500 kilopalm generator have been preserved, an incredible indicator for a tank of that time. Such a generator could power equipment to create high-intensity electromagnetic fields or serve as a power source for experimental beam weapons. The archives also contain drawings of a protection system against magnetic mines, with the creation of a compensating magnetic field around the tank. The system included a DC generator and a system of windings around the hull, which made it possible to significantly reduce the tank's magnetic signature. This was one of the world's first active magnetic protection systems, April 1945. Soviet troops are approaching Berlin, and 2 Maus prototypes are located at the test site in Kummersdorf. On April 21st, a direct order comes from the Führer's headquarters. Destroy all secret equipment so that it does not fall to the enemy. A crew of 8 people under the command of Chief Lieutenant Schmidt begins to carry out the order. The crew tries to blow up the V2 with the installation of 50 kilos of TNT, but the powerful armor withstands the detonation. Only the internal mechanisms are destroyed. Then the tank is doused with 1,000 liters of gasoline and set on fire. The internal equipment burns out completely, but the hull remains relatively intact. The V1 prototype, which did not have a turret, is decided not to be completely destroyed. Soviet tanks are already a few kilometers away, and there is no time to prepare a full-fledged explosion. The commander decides to simply disable the engine and gearbox. However, the main mystery is connected with the 3rd prototype. According to reports from the Krupp and Alket factories, by March 1945, hulls for 5 vehicles were ready, and the assembly of the 3rd prototype was being completed at a secret plant in Thuringia. When American troops captured this plant on April 14, 1945, they found almost empty workshops. Documents indicate that the equipment and unfinished hulls were taken to an unknown direction 2 weeks before the arrival of the Allies by a column of 20 trucks under the guard of an SS detachment. There are several theories about the fate of the 3rd Maus. 1. The tank was secretly taken to the USA as part of Operation Paperclip and studied at the Aberdeen test site, and then transferred for further research to Detroit too. The prototype is hidden in an underground complex in the Harz Mountains, along with other secret developments in the abandoned Martin Mine 3. The vehicle was captured by Soviet troops and sent for study to the USSR at Plant No. 100 in Chelyabinsk 4. The tank was destroyed by the Germans themselves during the retreat, but the traces of destruction were carefully hidden, covering the wreckage with soil 5. The unfinished hull was transported to neutral Switzerland or Spain to continue work after the war. In 2018, a group of German enthusiasts, using a modern ground-penetrating radar, discovered large underground voids in the Thuringia area, measuring 60-40 meters at a depth of 25 meters, where, in their opinion, the missing prototype may be located. However, they did not receive official permission for excavations. The local authorities referred to the danger of collapse and the possible presence of unexploded ordnance. Radar images show the presence of large metal objects of regular geometric shape. Despite the complete failure of the project as a combat unit, many technical solutions first tested on the Maus had a significant impact on post-war tank building throughout the world. Engineers from all countries carefully studied the captured prototypes and documentation. The electromechanical transmission, although not used massively due to complexity and high cost, became the prototype of modern hybrid power plants. The principle of independent drive of each driving wheel is used today in some promising developments, including the American Future Combat Systems and the Russian Armata. Modern systems provide efficiency up to 90% versus 65% for mechanical transmissions. The underwater driving system was improved by Soviet engineers and is used in a modified form in modern Russian tanks, including the T-72, T-80, and T-90. The depth of overcome water obstacles reaches 5 meters, using a new design snorkel with a system of valves and filters. The preparation time for overcoming a water obstacle has been reduced to 15 minutes versus 45 for the Maus. The combined armor of the Maus, consisting of steel sheets of different thicknesses and hardness, became the basis for the development of spaced armor and dynamic protection. The principle of differentiated protection, when different parts of the hull have different armor thicknesses depending on the probability of being hit, is today the standard for all main battle tanks. Modern combined armor provides protection equivalent to 800 1,000 mounts of steel armor. The fire control system with a stereoscopic rangefinder and an electromechanical ballistic calculator was ahead of its time by 15-20 years. Similar systems appeared on Western tanks only in the early 1960s on the American M60 and British Chieftain. Modern FCS include laser rangefinders, ballistic computers, and stabilization systems. But the principles laid down in the Maus remain relevant. Even the very concept of a heavy breakthrough tank found its continuation in the Soviet IS-7 and T-10 projects, as well as in the American M103. Although super-heavy tanks were eventually abandoned in favor of main battle tanks, many ideas were implemented in next-generation vehicles. For example, the barrel purging system with compressed air after a shot, first used on the Maus, became standard for all modern tanks. Analyzing the Maus project from today's perspective, and having access to all archival documents, several key fundamental errors can be identified that predetermined its fate from the very beginning. Each of these errors separately could have been fatal, and their combination made failure inevitable. The first and main mistake is the complete ignoring of the principle of correspondence of means to goals. The Maus was created as a tank for breaking through deeply echeloned defences, but its weight of 188 tons and dimensions, 10.2 Q3, 0.6703.63 m, made it impossible to use on most European theatres of military operations. It could not pass on standard roads, maximum load 10 to 15 tons, could not cross most bridges, maximum load 40 to 60 tons, could not be quickly transported by rail without special infrastructure preparation. Even a 90-degree turn required an area of 20x20 meters. The second mistake is the catastrophic underestimation of the importance of mobility and strategic mobility. In the conditions of maneuver warfare that German tank forces waged in 1943 and 1945, the 200-ton Colossus became an ideal target for aviation and artillery. Its low speed, 13 to 22 km/h, and poor maneuverability, turning radius 19 meters, made it vulnerable even to infantry with close-range anti-tank weapons. The time to turn 360 degrees was 2.5 minutes, a death sentence in close combat. The third mistake is complete disregard for economic efficiency. The cost of one Maus was estimated at 1.2 million Reichsmarks, the same as 25 Pz.Kpfw tanks or 12 Panthers. At the same time, the combat effectiveness of the Maus was more than doubtful. One knocked-out Maus meant the irretrievable loss of resources sufficient for an entire tank unit. The costs of producing one Maus would have been enough to maintain an infantry division for a month. The fourth mistake is technological overcomplexity to the detriment of reliability. The electromechanical transmission, underwater driving system, complex fire control system, all this required the highest qualifications of the crew and complex maintenance in field conditions, which was almost impossible to implement in wartime conditions. The mean time between failures was only 15 engine hours, an unacceptably low figure. The fifth mistake is strategic short-sightedness in conditions of total war. In 1944-1945, Germany desperately needed mass-produced, simple-to-manufacture, and maintain tanks. Instead of concentrating resources on proven models, they were spent on exotic projects that could not have a significant impact on the course of the war, even if successful. During the development of the Maus, Germany lost the opportunity to produce 300 additional Panthers. The sixth mistake is the psychological factor. Hitler and his entourage believed in miracle weapons as a panacea, which prevented a sober assessment of real capabilities and front needs. The Maus became a kind of symbol of this belief in a technical miracle, capable of saving the situation, contrary to logic and common sense. This was a classic solution looking for a problem error. Conclusion: the eternal symbol of technological madness in detail. The history of the Maus is not just the history of an unsuccessful tank, but a vivid example of how the technological race can lead to the creation of technically impressive but absolutely useless in real conditions models of weapons. This is an eternal warning against blind faith in miracle weapons, capable of turning the tide of war with a single stroke against all odds. The Maus became a symbol of how engineering genius can be directed into a dead end under the influence of political ambitions and technocratic illusions. The Maus became a symbol of the ambitions of the Third Reich, not supported by real opportunities and a sober assessment of the situation. It clearly demonstrates the danger when political ambitions and technocratic fantasies completely prevail over military expediency and economic reality. The project absorbed resources that could have been directed to the production of thousands of conventional tanks and distracted the best engineering minds of Germany from solving real problems. Today, the only surviving Maus in the Museum of Armored Weapons and Equipment in Kubinka serves as a clear reminder of this danger. It stands as a monument to engineering genius directed towards destruction, and as an eternal warning that the most advanced technologies are useless if they do not meet real needs and capabilities. Every museum visitor can see firsthand what neglect of the principles of practicality and expediency leads to. The history of the Maus makes us think, how many modern miracle projects in the field of weapons repeat its fate? Are we witnessing the creation of new mice technically impressive but practically useless? How many resources are spent today on projects that will never find practical application on the real battlefield? These questions remain relevant in the 21st century, when technologies are developing at a rapid pace. The Maus will forever remain in history as the largest, most mysterious, and most controversial tank of all times and peoples. A steel monster born in the last agonizing days of the Third Reich. An eternal symbol of technological madness and vain hopes for a miracle weapon capable of saving a doomed regime. Its history is a lesson that humanity must remember in order not to repeat the mistakes of the past in the future. This is a reminder that technologies should serve people and not become an end in themselves, and that even the most perfect technical solutions are useless if they do not meet real needs and do not take into account the limitations of the real world.